Right, for this problem we are asked to find the cosine of the arc cosine of the negative square root of 3 over 2. Just as a reminder here, if you do not care for the arc cosine way of phrasing the problem, this is the same thing as cosine inverse. So if you prefer to look at this as the cosine of the cosine inverse of the negative square root of 3 over 2, that's also fine. Now, due to the restrictions on where we are allowed to have inverse cosine answers, do not automatically assume that the cosine and the inverse cosine are just going to cancel themselves out. That might happen, but we need to work out exactly what's going on to verify. Don't just make the assumption that is a sure way to the path of destruction and ruin for your grade. So what we're going to do is we are going to treat this like an order of operations concern here, and we'll focus on doing the cosine inverse of the negative radical 3 over 2. Now remember, the answer for an inverse cosine is going to be an angle theta, and for inverse cosine, our answers for theta have got to be in quadrants 1 or 2, meaning they're between the values of 0 and pi. If cosine is going to be a negative value, that means we're going to have to be in quadrant 2. Alright, so that's our giveaway for quadrant 2. So we're going to go ahead and draw our coordinate axes and draw our right triangle here in quadrant 2. Try to give ourselves enough room to do some work. Now, cosine is equal to the adjacent over the hypotenuse. So that'll be the negative square root of 3 over 2. And with a little help from the Pythagorean theorem, we will discover that the missing side is 1. Now remember that our reference angle is here, between the hypotenuse of the triangle and the x-axis. Right, so that takes care of the right triangle and where it's going to be oriented. As it happens, this would be an angle measure of 30 degrees, because this would be a 30, 60, 90 right triangle, which as a radian measure would be pi over 6. So when we're looking for the cosine of the cosine inverse of negative square root of 3 over 2, this is the same thing as looking at the cosine of 5 pi over 6. Now remember, it's going to be 5 pi over 6 because the pi over 6 here is our reference angle. So what we want to do is start at 0 and then head all the way around counterclockwise. So that's going to be our 5 pi over 6. So now we're going to take the cosine of that 5 pi over 6. So we're still with the same reference angle here with our theta. This is still the same 30, 60, 90 triangle. We didn't have to do any shifts in orientation. Cosine is still the adjacent over hypotenuse. So this did wind up giving us the negative square root of 3 over 2 for our final answer. We're asked to simplify tangent of the inverse sine of 5 over 13. We're not going to get too bogged down in kind of the nuances of what's going on here. We're just going to focus on taking care of what's inside the parentheses first, that inverse sine of 5 over 13. So now remember that that's going to give us an angle, which we'll call theta, which also means that the sine of theta is going to equal 5 over 13. Right now, the restrictions on inverse sine tells us that theta has to be between negative pi over 2 and pi over 2. Meaning this has to be in quadrant 1 or quadrant 4. Since what we're looking at here inside that inverse sign is positive, we're going to be in quadrant 1. So we'll draw ourselves a triangle in quadrant 1. Here's our angle theta. We'll go ahead and label the relevant sides here. So sine is opposite over hypotenuse, so that'll be a 5 and a 13. Through your friend the Pythagorean theorem, you'll discover the adjacent side is of length 12. Right, that just took care of the inverse sine component. Now, since this is going to give us some angle theta, we're now going to turn around and take the tangent of that angle theta. You might be feeling a bit concerned because we don't know the measure of angle theta. Don't be concerned about finding the measure of angle theta, because even if we were able to get this to say, all right, theta equals, I don't know, 25 degrees, we're just going to turn around and take the tangent of that angle anyways. So basically, theta is our reference point only. And now we're going to use the tangent, which is the opposite over the adjacent, which is going to give us 5/12. And that's our final answer. For this problem, we are looking to simplify the cosine of the arctan of negative 24 over 7. So what we're going to do first is just worry about the thing inside the cosine's parentheses, the arctan of negative 24 over 7. Now, arctan can also be written as tangent inverse. So if you prefer to look at the problem this way, that is perfectly acceptable. But in either event here, we're going to have our tangent inverse of negative 20 over 7. Now remember, that's going to give us an answer of an angle, which we're going to call theta. Now because tangent inverse is going to be equal to theta, that also means that the tangent of this angle theta is going to be a negative 24 over 7. But don't forget that tangent inverse has a restriction on the range, and that is that our angle theta has to be between negative pi over 2 and pi over 2. It doesn't get to include either the negative pi over 2 or the pi over 2, but anything else is fair game. So that means we're going to be looking at a triangle that's either in quadrant 1 or quadrant 4. Now because of the negative sign here for our inverse tangent, that tells us we're going to be in quadrant 4. So we'll go ahead and draw our right triangle in quadrant 4, like so, and our reference angle, at least, will be here for our theta. Now, since tangent is going to be equal to negative 24 over 7, and that's going to be our opposite over our adjacent side. Now we just need to make sure we put the negative in the right place. In quadrant 4, the x values are positive, so the 7 is fine as is, but the 24 then needs to become negative. Because we're going to be looking at the cosine that's going to involve the hypotenuse at some point, we're going to go ahead and use the Pythagorean theorem, and we will discover that our missing hypotenuse length is 25. So now we're going to just look at the cosine of our angle theta, which we got from our inverse tan. And so, using this as our reference angle, cosine is the adjacent over hypotenuse, so that'll be a positive 7 over 25. And that's all there is to it. We just don't need to know what the measure of that angle theta is to answer this problem, which is good because there's no way that would come out nice and pretty. So our final answer here is 7 over 25. So now here we have a problem we're trying to simplify the sine of the inverse tangent of x for where x is greater than 0. Now when you first look at this, you might have a tendency to want to curl up in the fetal position a little bit or maybe cry a bit on the inside, but this isn't nearly as bad as it first seems. We're going to treat this just like we would any other problem, and we're going to focus on getting what's inside the parentheses represented first. So that's our inverse tangent of x. Alright, so now inverse tangent of x is still an inverse trigonometric function, which means the answer here is going to be an angle theta. Alright, what this also means is that the tangent of that angle theta is going to be equal to x. Alright, keep in mind that our answer for inverse tangent to give us that angle here has to be between negative pi over 2 and pi over 2. Now, since we know that x is going to be strictly greater than 0, that's going to fit somewhere between that 0 and pi over 2 then, so we know we're going to be in quadrant 1. All right, so we're going to go ahead and draw our right triangle here in quadrant 1, like so. So right angle, and here is what we're going to call our theta. All right, now here's where things can tend to get a little bit tricky. What we've got here for our tangent of theta is just x, which doesn't really help us. We're used to seeing it as ratio of sides of the triangle, which is in fact what we have. It just is a slightly unconventional look. X can also be written as x over 1, so thus giving us our ratio for the tangent of our angle theta. X over 1, tangent is the opposite over the adjacent, so that'll be one side, or the opposite side is x, the adjacent side is r1. We still need to figure out what our hypotenuse is going to be if we're going to be dealing with the sine of that angle theta. In order to do that, we're going to go back to the Pythagorean theorem, and I think this one will actually benefit from us working it out on screen here. All right, so the Pythagorean theorem, we have a squared plus b squared equals c squared, where a and b are the legs of our right triangle. That would be our x and r1, and c is going to be the length of our hypotenuse. Right, so this gives us our x squared plus 1 squared to equal c, our hypotenuse, squared. X squared is just x squared. That doesn't really do anything exciting. 1 squared is 1. And this has to be what our c squared is equal to, but we need c to be by itself, so we're going to square root both sides, and so c is equal to, well, nothing simplifies here because we can't just take the square root of each piece individually because of the addition, so we're just leaving this as the square root of x squared plus 1, and that is our hypotenuse. But this was all done in an effort to figure out the sine of our tangent inverse of x. But remember, tangent inverse, it just gave us an angle, which we called theta, or at least I did, and you're listening to me, so you get to follow along with thetas. All right, now theta was our guy here. So now we just need to take a look and figure out the sine of that angle theta. All right, so sine is the opposite, which is x over the hypotenuse, which was our square root of x squared plus 1. Ideally, we'd be able to simplify at this point. Unfortunately, there is no simplification that can take place. So this is our final answer, x over the square root of x squared plus 1.